Hello everyone, welcome to my class. Hope you all are doing great in your life. Today we are going to discuss some more concepts on measurement. Okay, so without wasting time, let's start the class. Students, let us now discuss about the units of time. We have already discussed that SI unit of time is second, which is represented by small s. So how can we define second? A second can be defined as the 1 by 86,400 part of a mean solar day. What is a mean solar day? A solar day is the time taken by Earth to complete one rotation around its own axis. So it is 24 hours, and we know that 1 hour is 3600 seconds. So solar day is equal to 24 into 3600, that gives us 86,400. So 86,400 seconds is one solar day. That means 1 second is 1 of 86,400 seconds. So it is 1 by 86,400 seconds. Okay? Hope you understand. Students, let us now discuss some smaller units of time. Okay? So millisecond, microsecond, shake and nanosecond are the smaller units of time which we generally use. Okay? So millisecond is equal to 10 to the power minus 3 second. Okay? Microsecond is 10 to the power minus 6 second. Shake is 10 to the power minus 8 of a second, and nanosecond is 10 to the power minus 9 second. Okay? You just need to remember the relationship, so it will help you when you need to convert different units of time. Okay? Students, let us now discuss about some bigger units of time. Okay? After second, if we go up, we find minute. 1 minute is 60 seconds. 1 hour is 60 minutes. So 60 into 60, that is 3600 seconds. 1 day or one solar day, that is 24 hours. That is 24 into 60 into 60, that is 86,400 seconds. Then month. We have three types of months. A month having 30 days. And February contains either 28 days or 29 days. Okay. So 30 days month are April, June, September and November. 31 days month are January, March, May, July, August, October and December. So what about February? In each leap year, month of February contains 29 days. We will talk about leap year later on. Okay. So this is the first set of bigger units. So let us now discuss about the second set of bigger units. Okay, students, let us now discuss about lunar month. Okay, see, the western or the Gregorian calendar is based on the revolution of Earth around the sun, and it is in use in general. Okay, but in Hindu religion, Bikram and Shak, and in Muslim religion, Hijri calendars are used, which are based on lunar month, and it depends upon the phase of the moon. And 1 month in that case is 29.5 days. And 1 year is 354.37 days. That means it has a deficiency of about 10 days. Okay. So you need to remember these data for any future references or for any kind of use. Okay. Students, next bigger unit of time is year. What is an year? It can be defined as the time taken by Earth to complete one revolution around the sun, and it is 365 days. Students, let us now discuss about leap year. A leap year that falls every 4 years. That means once in a 4 year, there would be a leap year having 366 days. Why does it happen? Because the exact period of revolution of Earth around the sun is 365.2422 days. But we consider it as 365 days. So every year there is an extra amount of 0.2422, which amounts to 1 day in every 4 years. That is why every 4 years the number of days is 366 days, and that is included in the month of February, as we have already discussed. Okay, so how we can recognize the leap year? A leap year is a year that is divisible by number 4 because it falls every 4 years. For example, 2024 divided by 4. So it gives us 506. That means it is divisible by 4. So 2024 is a leap year. So after 2024, 2025, 2026, 2027, 2028. So next leap year would be 2030. up to 8. Okay, because it is also, see, it is also divisible by 4. The last two digits is divisible by 4. That's why the number is divisible by 4. So in that way we can find out which is a leap year and which is not a leap year. Okay. Students, next bigger units are decade and century. Okay, so decade is 10 years. So when we multiply 10 with the seconds for 1 year, we get 3.1536 into 10 to the power 8 seconds. A century is of 100 years, out of which 24 years is of 366 days and 76 years are of 365 days. So they sum up to 36524 days. And we know that 1 day is equal to 8.64 into 10 to the power 4 seconds. So that will be then 1 century will be equal to 8.64 into 10 to the power 4 into 36524, because the century has these many days. So it will give us 3.16 into 10 to the power 9 seconds. Okay, hope you understand. Students, next bigger unit is millennium, which is equal to 1000 years. So 1000 years, see, 1 century is 100 years. That means if we divide it by 100, we get 10 centuries. Isn't it? So we have found out that 1 century is equal to 3.16 into 10 to the power 9 seconds. So 10 centuries, 1 millennium would be equal to 10 into 3.16 into 10 to the power 9, that is equal to 3.16 into 10 to the power 10 seconds. Okay, so this is the relationship between millennium and second. Students, in our earlier classes we have discussed that there are two types of units, that is fundamental units and derived units. Derived units are constructed out of the fundamental units, or we can say that derived units are the combination of fundamental units. Okay, so let us take some example. When we think about the unit of speed, unit of speed, that is, speed is distance upon time. So we need to go for the unit of distance, which is nothing but the length, and time to find out the SI unit of speed. So what is SI unit of length? That is meter, and SI unit of time is second. So unit of speed is nothing but meter per second, or it is also written as meter second to the power -1. So this is a derived unit, which is the combination of two fundamental units. Okay, we can have many more examples like this. So the derived units are listed in the following table. Okay. Students, let us now discuss the guidelines for writing the units. Okay, the symbol for a unit which is not named after a scientist is written in small letter. For example, meter, which is written as M, second written as S, small s and small m. Okay, which is named after the name of a scientist is written with first letter of the name in capital. For example, Kelvin, it is the unit of temperature, SI unit of temperature, which is written as capital K. Newton, it is written as capital N. Okay, but if we are writing the units in their full form, the full name of the unit, then irrespective of the name of the unit, if it is from the name of a scientist or not, it is always written in small letters. That means the name starts with a small letter. Full name of the unit starts with a small letter. For example, Kelvin, meter, second, Newton. If we represent Newton in single letter, then we have to write capital N. But if we are writing the full name, we need to start with the small n. Compound unit formed by multiplication of multiple units is written with a dot in between. For example, unit of torque is Newton meter, but Newton meter is written as N capital dot M. Newton dot meter. We can write it as N into M or Nm. Negative power is used for compound unit formed by dividing one unit by another. For example, unit of speed, distance by time, meter per second, meter divided by second. So, ms to the power minus 1. We cannot write it as ms to the power minus 1. Okay, you might have learned about the exponent and power. So, m divided by s means s to the power 1. So, when it comes up, it gives us ms to the power minus 1. This is not the way to write the unit. Okay. A unit in its short form is never written in plural. For example, meters is the plural of meter, but we cannot write ms in the plural form of meter. We need to write only m. To avoid power of 10, units are written using appropriate prefix, but more than one prefix is not to be used. For example, this is kilo megawatt. Kilo means 1000, 1000 megawatt. We can write it as gigawatt. We need not to write kilo megawatt. We can use the prefix of higher units, but we cannot use more than one prefix. When prefix is used with symbol of unit, the combination becomes the new symbol of unit. For example, kilometer cube. Km cube, K is the prefix, M is the unit, kilo means 1000, that is 10 to the power 3. So, kilometer becomes the new unit, that means kilometer cube means 10 to the power 3 meter cube, and it gives us 10 to the power 9 meter cube. We cannot write it as 10 cube meter cube. Okay? Students, today we have learned some concepts on measurement. Hope you have understood everything clearly. If not, please watch the video again, go through the book, revise again and again to keep those concepts in your mind. Okay? So, as I always say, keep revising, keep practicing, and most importantly, keep smiling.